Hi, in this video we're going to take a look at database indexing and in particular a quick demonstration of how much effect creating an index can have on queries that actually make use of that index. Well, to make it all very simple, we're going to use a very simple database called GeoNames, which is available for public access, which contains information about places on Earth. They're stored in the GeoNames table, and the only other table in the database is a countries table. This query here is actually just using a function that I wrote that will count the number of tuples in each table, and using this we can see that there are 8 million entries in the GeoNames table and 250 in the countries table. So there aren't that many countries on Earth, but there are a lot of places that are referenced in the GeoNames table. Alright, for the purposes of this video I'm going to turn timing on in the database, and let's take a look at the details of the GeoNames table. Okay, you can see that it's got a primary key integer and a bunch of fields of varying sizes, and some are quite large, so potentially this is a very large amount of data, large tuples and a lot of those tuples, so 8 million tuples potentially, each very large. Alright, so lots of data. In order to solve queries on this table, we potentially have to scan through lots of data. Alright, well the table already has 2 indexes on it. It's got an index on the primary key. Remember that every Postgres table that has a primary key has a B-tree index built on the attribute that is the primary key. There's also an index on this table that I created earlier on the name attribute, so I can look up places by name. Alright, so let's start looking at how long queries are going to take. Now I'm not actually going to fetch the tuples for any of these queries because the tuples are large and they'll make a mess on the screen, so I'm simply going to count the number of results that would have appeared in each of the queries. And in fact, doing a count or fetching all of the tuples is going to take roughly the same amount of time. So if I wanted to count the number of tuples in the GeoNames table, we know it's 8 million, we saw that before. Let's just see how long that takes. So there was a noticeable delay, and it takes 1100 milliseconds, which is basically 1 second. So anytime you get a query that takes more than around half a second, there's a noticeable delay, and you'd like to avoid things like that in any systems that happen to make use of a database. Alright, let's ask something more specific. We can ask for a tuple matching a particular ID, one that I happened to prepare earlier. And so if we ask this query, there's going to be exactly one result. It's going to use the index to fetch that result, and as you can see, it's extremely fast compared to that. If I was to ask a query on the other indexed attribute, on the name attribute, and let's just ask for Sydney, then it's also going to use an index, and it should similarly be quite fast. Now there's not going to be just one result because there are a number of places in the world that happen to be called Sydney. There are in fact 12 of them, and it takes 3 milliseconds, so 0.003 seconds. So that's fast, that's fast, that's not fast. Alright, let's see what happens if we don't use the index, and we can force that by using patterns. So if I specify a pattern on the name, then I can't simply look up that key value directly in the index. I have to scan the table and find all things that match that pattern. Now of course this is going to match other things like North Sydney, or Sydney East or whatever, so it's not going to have the same number of results as this, but it'll have a relatively small number of results. But we can see that there's a noticeable delay, has 200 results, but it's taken well over a second to discover those results. So the use of an index results in extremely fast times. The use of a pattern is definitely not as fast. Now, one thing I could do, I could drop the index that I've got on the table, geonames name index. Dropping the index is quite fast. To actually create that index took 5 minutes. So that's one thing to be aware of when using indexes. Indexes create a little bit of overhead when you insert tuples. If you wait till you insert 8 million tuples and then try to index them all at once, it's obviously going to take a long time, but each individual insertion has to update the index, so there's a little bit of overhead that you incur there. But I think you'll see that the cost at query time is definitely worth having an index. So up here is the time asking that same query when we had an index, and here's the time cost to ask the query where we don't have an index. So indexes are a valuable tool if you happen to know what kind of queries are being asked on the database. So if I happen to know that frequently I'm going to ask queries of this type, then setting an index on that attribute is a very good idea. So indexes can be a very useful tool in improving the performance of databases. Okay.